Three cars from three different brands from three different countries, but telling the same story. The Holy Trinity, as this trio of hypercars is known, has created a new milestone in the automotive industry, a new peak of performance. But what makes these three cars so revolutionary, and who are they? First, let's go back to 1886, when the first internal combustion car was created. I would say that, at that time, Carl Benz had no idea where his idea could lead more than a century later. At that moment, just the idea of a horseless carriage, a machine capable of going from one place to another by its own power, was already impressive. 13 years later, in 1899, Camille Yanazzi solidified his invention, La Jamais Contente, as the first car to surpass the 100 kilometers per hour barrier. Since then, automotive technology has been gradually improving. Combustion engines began to be more efficient, becoming smaller, lighter, less fuel-consuming, yet more powerful. Revolutionary technologies like turbochargers emerged, as well as new materials that made cars increasingly lighter and more durable. Even electric motors, their batteries, and the way electric energy is used in automobiles became more efficient. It was then that, in 2013, Ferrari, McLaren, and Porsche launched their hybrid hypercars, which were the pinnacle of performance and technology for each brand at the time. In a manner similar to what the Porsche 959 did in the 80s, the 918 did in 2010 by bringing racing car performance to the streets and breaking boundaries. In the powertrain is an engine with the same architecture as the one used in the RS Spyder at Le Mans. It is a naturally aspirated 4.6-liter V8 with 608 horsepower and 540 Newton-meters of torque, capable of revving up to 9,150 revolutions per minute and weighing only 135 kilograms. However, its biggest differentiator lies in the two electric motors, one on the rear axle with 156 horsepower, connected in parallel with the combustion engine and linked to the 7-speed dual-clutch PDK transmission. There is also one on the front axle, which is connected to the wheels with a single-gear ratio and is decoupled at high speeds to prevent over-revving. This engine produces 129 horsepower and makes the 918 an independently all-wheel drive car. The electric part is not simply there to raise the car's power to 887 horsepower, but mainly to make the most of both types of engine. For this, the car has 5 driving modes that control the working dynamics of the combustion engine and the electric motors and alter the car's aerodynamics. Let's start with the simplest ones. The e-Power mode, which is purely electric and has a range of 19 kilometers, and the hybrid mode, which is focused on reducing the vehicle's consumption, being capable of achieving up to 3.0 liters per 100 kilometers. In these modes, the rear spoiler lowers, the car's floor panels close, as well as the flaps under the headlight. However, since these flaps allow air passage for cooling, when the car is stationary, they open. And as soon as it starts moving, they close again and only open when the car reaches 81 miles per hour or when better cooling is needed. In sport hybrid mode, the internal combustion engine is assisted by the electric motors in the form of electric boosting. In the aerodynamic section, the rear wing remains raised, but with a smaller angle of attack, which allows for higher speeds. To assist, the floor panels remain closed to reduce drag, and the flaps below the headlights stay open all the time. In hybrid race mode, the combustion engine will always be operating at high loads and regenerating the batteries when the driver is not using maximum power. In addition, the PDK transmission will be configured for an even more sporty experience, and the electric motors will operate at their maximum potential. At this moment, it is normal for the battery charge to fluctuate frequently, as energy consumption will increase. However, according to Porsche, you will hardly have problems with a lack of energy. Regarding aerodynamics, the rear wing extends and tilts at a steep angle, the floor panels open, and the flaps below the headlights remain always open to ensure cooling. There is also a hot lap mode, which can be activated by the red button in the center of the switch. This mode will use the entire battery of the car to deliver the maximum performance possible, but only for a short period of time. Regarding the weight, despite the electric system representing a significant challenge due to the weight of both the motors and the batteries, the car weighs less than 1,675 kilograms. This was made possible thanks to the use of materials like aluminum and magnesium, especially in the engine, which is made almost entirely of these, in addition to a carbon fiber reinforced plastic composite in the monocoque and polyurethane panels. Even so, if you pay a little more for the Weissach package, the car loses another 40 kilograms with new magnesium wheels and a greater abundance of carbon fibers. To prove its full potential, Porsche decided to put the car to the test on one of the most famous circuits in the automotive world, Nürburgring Nordschleife. Right on their first time driving the 918 Spyder Weissach package, the test drivers already broke the track record. The fastest time set that day was, incredibly, 14 seconds faster than the previous record, and this new record lasted for 4 years. The entire circuit was completed in 6 minutes and 57 seconds, with an average speed of almost 180 kilometers per hour. It is worth noting that all this performance comes from a car that has a removable roof with the exhaust system on top, very close to the driver. This ensures a unique and immersive experience worthy of a $1 million car with only 918 units. For me, seeing supercars racing on tracks and delivering truly special driving experiences is much more interesting than just looking at mere acceleration and top speed numbers. Since 1993, with the launch of the McLaren F1, McLaren made it very clear that it was not just another factory in the automotive industry. The McLaren F1 redefined the concept of a supercar, bringing with it not only surreal performance but, above all, numerous technological innovations, such as the first street car with a carbon fiber monocoque. Almost 20 years later, McLaren did something similar, introducing the world to its new hybrid, McLaren P1. The P1 is powered by a 3.8-liter twin-turbo V8 engine based on the engine from the McLaren 12C. Alone, it produces 737 horsepower, but within the same block is incorporated the electric motor iPass, or Instant Power Assist System, which raises the power to 916 horsepower. This engine, weighing only 26 kilograms, can be activated either by a button on the steering wheel or automatically by the car to compensate for moments when the combustion engine is not as efficient, such as during gear shifts or while the turbos are spooling up. In general, a hybrid system is an alternative to minimize the supposed damage caused to the environment by combustion engines. However, McLaren did the opposite. She used the idea of combining two different types of energy to maximize the potential of the beloved ICEs. To achieve the maximum performance that an engine can deliver, aerodynamics must be as advanced as possible, and McLaren did an excellent job in this area. The main aerodynamic highlight of the P1 is its giant and movable rear wing. This characteristic of being movable is fundamental, since if it were fixed, when the car reached speeds close to its maximum speed, the suspensions simply wouldn't withstand all the pressure and would break. To overcome this problem, it would be necessary to reinforce them, which would add a lot of weight, or to make the wing movable, and that is what McLaren chose. In race mode, the car lowers by 50 millimeters, the suspension becomes 3 times stiffer, the spoiler lifts, and is set at a 29-degree angle. All of this allows the car to produce up to 600 kilograms of downforce, making it the street car with the highest amount of downforce made up to its release date. On the steering wheel, there is also a DRS button, which works on the same principle as the F1 DRS, reducing drag to achieve higher speeds on straightaways. When this button is pressed, the wing tilts to a 0-degree angle and reduces drag by up to 23%. The result on the track is a lateral acceleration of over 2G and an experience comparable to Le Mans cars, according to Simon Lacey. The innovations don't stop here. After all, having very powerful engines and unmatched aerodynamics is useless if the car weighed 3 tons. However, it weighs only half of that, 1,490 kilograms, even with all the necessary fluids included for operation and more than 90% of the tank full. Simply impressive. This made the P1 the lightest car with the highest power-to-weight ratio of the Holy Trinity. There is weight relief everywhere. The monocoque, which integrates from the roof to the I-Pass battery compartment, is made entirely of carbon fiber and weighs only 90 kilograms. The fibers used are more than twice as rigid as steel and more than 5 times stronger than the best titanium. Even the windows were made to be thinner, saving 3.5 kilograms. The seats, following the same principle, have fixed backs at an angle of 28 degrees, or 32 if requested for more helmet space. Inside, there are no carpets, as they are an unnecessary weight. Everywhere there are exposed carbon fibers with a matte finish in order to save 1.5 kilograms. The result of all this, in numbers, was a car capable of going from 0 to 100 in 2.8 seconds, 0 to 300 in 16.5 seconds, and a top speed of 350 kilometers per hour. There are also other even more powerful versions, the P1 GTR and the P1 LM. Briefly, the P1 GTR is the most extreme version of the P1, as it does not have the limitations required for street legality, while the LM version is the street version of the GTR, made by the brand Lanzante with McLaren's authorization. This last model broke the Nürburgring record for street legal cars in 2017. Lanzante was also responsible for creating a Spyder version of the P1, which is the only one in the world. Having a P1 is like having a jewel. More than a design, it is a work of automotive engineering art. And like all art, it must be exclusive. So McLaren produced only 375 units, which were sold at an initial price of over $1 million. In celebration of the brand's 70th anniversary, Ferrari decided to join forces to create a car that was as powerful, lightweight, aerodynamic, and beautiful as possible. Thus, the Ferrari, or in Italian, LaFerrari, was born. The car performed so well that it broke the track record at Fiorano, being an incredible 5 seconds faster than its predecessor, the Ferrari Enzo. Just like the 918 Spyder and the McLaren P1, the LaFerrari has a hybrid system. At the heart of the beast is a naturally aspirated 6.3-liter V12 with 800 horsepower, capable of revving up to 9,250 RPM. Until the time it was launched, it was the most powerful naturally aspirated engine ever mounted in a street car. Working together, there is a 163 horsepower electric motor, totaling 963 horsepower. However, unlike the other 2 cars, it is not possible to drive solely with the electric motor, as, according to the brand, they are not interested in electric cars. Good or bad, the fact is that the 2 engines work better together. When the combustion engine produces more torque than necessary, such as in curves, this excess is used to recharge the batteries. Since the electric part can deliver a lot of torque at low revs, the engineers adapted the V12 to be more efficient at high revs, allowing the combined maximum torque to exceed 900 Newton meters. This hybrid system, however, did not increase either the length or the wheelbase of the car. In fact, it allowed for a lowering of the center of mass. The weight reduction of the LaFerrari occurs at several points. The batteries, for example, are made up of 120 cells mounted in 8 modules, with a power equivalent to 40 traditional batteries, yet weighing only 60 kilograms. The seats are mounted to the chassis, and the only adjustments you can make are to the pedals and the steering wheel, which allows for a reduction in both the car's weight and height, as well as the height of the driver's position. This position was tested by Formula One drivers to ensure it was as efficient and comfortable as possible. In addition, throughout the car there are 4 different types of carbon fiber. The extra high-strength carbon fiber, also called T1000, which is used in the doors and was used in the nose cones of Formula One cars. The T800UD, which is made up of unidirectional fibers. The M46J, which is extremely rigid yet lightweight, used in the general structural parts. And, for the bottom of the car, a mixture of carbon fiber and Kevlar was used. In terms of aerodynamics, the LaFerrari does not disappoint. The car features active aerodynamics both at the front and rear, with flaps that allow or prevent airflow through the floor, movable diffusers at both the front and rear, and a hidden spoiler. Without any activation, it is possible to produce only 90 kilograms of downforce at 200 kilometers per hour, but with everything activated, it rises to 360 kilograms. Right behind the front wheels, there is an air outlet that relieves the high pressure generated by the spinning wheels and channels that air to the radiators at the back. Above the rear wheel arch, there are two air intakes, which can add up to 5 horsepower to the engine as speed increases. The air outlets on the top of the car also have an aerodynamic function and help create downforce. The entire car was designed based on computational simulations, also called CFD or computational fluid dynamics, and refined in the Formula One wind tunnels. For those who like numbers, the LaFerrari goes from 0 to 100 in 2.7 seconds, and from 0 to 300 in 15 seconds, with a top speed of 355 kilometers per hour. Of the 3 hybrids that make up the Holy Trinity, the LaFerrari is the most expensive, costing over £1 million right at launch. Among other factors, this is due to its exclusivity of only 499 units. Subsequently, Ferrari launched a model with a removable roof called the LaFerrari Aperta with only 209 units. And for those who are even luckier and even more passionate about the performance of these Italian supercars, 40 units of a track-only version were made. This version, called the FXX-K, produces over 1,000 horsepower and weighs 90 kilograms less than the LaFerrari, and it also has an upgrade called the FXX-K Evo, which produces 27% more downforce. Without a doubt, these 3 cars have made their mark in history. If the world demands fewer emissions and car enthusiasts demand more performance, hybrid systems come to reconcile the two. But what about you? Do you like mixing combustion with electricity, or do you prefer cars to be like in the early days? We can discuss this here in the comments. Just don't forget to subscribe to the channel and share the video. See you next time.